Students, welcome to this, my last conceptual lecture covering nuclear chemistry. In today's lecture, I'm going to teach you about nuclear fusion and where babies come from. Are you ready? Let's get started. So, nuclear fusion is the process of fusing together lighter weight atoms to form heavier ones. This process gives off even more energy than nuclear fission that we talked about in our last lecture. Nuclear fusion is the process that fuels our sun through the following set of reactions that you're welcome to pause here and look at more closely if you wish. Nuclear fusion is an attractive potential source for energy production because light elements such as hydrogen and helium shown here are very abundant, and nuclear fusion produces little if any radioactive byproducts, which contrasts with nuclear fission where you have to start with polonium and uranium and stuff like that. The problem with nuclear fusion is that it requires very high temperatures in excess of 40 million kelvins to get started. On Earth, such temperatures have only been achieved by detonating thermonuclear or hydrogen bombs. But, you might ask, what about cold fusion? Well, according to Wikipedia, cold fusion is a hypothetical type of nuclear reaction that would occur at or near room temperature, compared with temperatures in the millions of degrees that is required for hot fusion. It was proposed to explain reports of anomalously high energy generation under certain specific laboratory conditions. It has been rejected by the mainstream scientific community because the original experimental results could not be replicated consistently and reliably, and because there is no accepted theoretical model of cold fusion. Cold fusion gained worldwide media attention after reports in 1989 by the University of Utah's Stanley Pons and Martin Fleischmann, then one of the world's leading electrochemists, that their apparatus had produced anomalous heat, excess heat, of a magnitude they asserted would defy explanation except in terms of nuclear processes. They further reported measuring small amounts of nuclear reaction byproducts, including neutrons and tritium. The small tabletop experiment involved electrolysis of heavy water, or D2O, on the surface of palladium electrode. The reported results received wide media attention and raised hopes of a cheap and abundant source of energy. Many scientists tried to replicate the experiment with the few details available. Hopes fell with the large number of negative replications, the withdrawal of many positive replications, the discovery of flaws and sources of experimental error in the original experiment, and finally the discovery that Fleischmann and Pons had not actually detected nuclear reaction byproducts. So Fleischmann and Pons went from being briefly very famous and very cool and cutting edge to being slightly infamous and probably a little bit of laughing stocks. We'll now read a few paragraphs under the cold fusion heading at Wikipedia's article linked to right here, just because I think it's interesting. Martin Fleischmann was a British chemist noted for his work in electrochemistry. Premature announcement of his cold fusion research with Stanley Pons regarding excess heat in heavy water led to their names being identified with the frenzy, controversy, and backlash that followed, although they continued their interest and research in cold fusion. Fleischmann confided to Stanley Pons that he might have found what he believed to be a way to create nuclear fusion at room temperatures. From 1983 to 1989, he and Pons spent $100,000 in self-funded experiments at the University of Utah. Fleischmann wanted to publish it first in an obscure journal and had already spoken with a team that was doing similar work in a different university for a joint publication. The details have not surfaced, but it would seem that the University of Utah wanted to establish priority over the discovery and its patents by making a public announcement before the publication. In an interview with 60 Minutes on 19th of April 2009, Fleischmann said that the public announcement was the university's idea and that he regretted doing it. The decision would later cause heavy criticism against Fleischmann and Pons, being perceived as a breach of how science is usually communicated to other scientists. I have to interject here and say that for those of us who are professors and those of you who may become professors, please make sure that you learn the lesson from this experience, that you should never listen to your administrators. Okay, I'm just kidding, but we'll go on. On the 23rd of March 1989, it was finally announced at a press conference as a sustained nuclear fusion reaction, which was quickly labeled by the press as cold fusion, a result previously thought to be unattainable. On 26th of March, just 3 days later, Fleischmann warned on the Wall Street Journal report not to try replications until a published paper was available 2 weeks later in Journal of Electroanalytical Chemistry. But that did not stop hundreds of scientists who had already started work at their laboratories the moment they heard the news on March 23rd. And more often than not, they failed to reproduce the effects. Those who failed to reproduce the claim attacked the pair for fraudulent, sloppy, and unethical work, incomplete, unreproducible, and inaccurate results, and erroneous interpretations. When the paper was finally published, both electrochemists and physicists called it sloppy and uninformative, and it was said that had Fleischmann and Pons waited for the publication of their paper, most of the trouble would have been avoided because scientists would not have gone so far in trying to test their work. Fleischman and Pons sued an Italian journalist who had published very harsh criticisms against them, but the judge rejected it, saying that criticisms were appropriate given the scientists' behavior, the lack of evidence since the first announcement, and the lack of interest shown by the scientific community, and they were an expression of the journalists' right of reporting. Fleischman, Pons, and the researchers who believed that they had replicated the effect remain convinced that the effect is real, but the general scientific community remains skeptical.